what's up guys? Alright, so today we are going to go into the second part of your log. Okay, we are technically at the end of the chapter, right? So today I think will be a very short video. So once we finish this part, basically we have already completed chapter 4. Alright, so without wasting time, let's get into it. Okay, this is about conversion of base. Now, for log, okay, given a base number here is 15, right? We can actually change the base number for a log by using the formula here. Alright, the change of base in a logarithm, okay, meaning I can actually change this into this, okay. So this will be the same base number. So in other words, if let's say I have a question and they ask me to solve, let's say for this, alright, okay, so log base 2 5. So if I want to solve this, I can actually use this formula to calculate. So technically the easiest way is to change it to base 10 log. So meaning log 10 5 divided by log 10 2. Okay, so when you change into the base 10 log, it is easier because you can punch in your calculator. You just punch log 5 divided by log 2 and then you will get your answer. Alright, so important thing here is to remember when you change the base, okay, when you change the base, you need to remember that, alright, the one on top stays on top, the one at the bottom stays bottom. Alright, so this is top and then this one is bottom. Okay, so this is how we change a base in log. Okay, this is very useful in your calculation. Alright, in many instances you might be using this what they call change of base to help you solve a lot of problems. Okay, so make sure you understand the concept. Alright, not necessarily we can change it to 10, we can change it to other values depending on the question itself. Okay, so let me show you another example, an exercise that we have did previously, alright, involving the solving equation part. Okay, this one. So previously we did this, we let it into unknown, right? And then we shift the log to the other side and then we change it into the index form basically. But if I do not want to use the index form, I can use the change of base to actually solve this question. So I change this into base 10 log. So log 10 64 divided by log 10 2. Okay, and then you just punch in your calculator log 64 divided by log 2, and then you should be able to get the same answer, which is 6. Okay, so that is how you can solve any log number by using the changing of base. Alright, a lot of students, they will prefer to use this to solve because it's easier. You can just punch in your calculator. Okay, and an important thing that I need to stress out is this. I know some of you are very creative one, the super creative type one. Okay, this thing you cannot, okay, it's not same as this. Alright, please remember that this thing is different than this. So a lot of the very creative one, so after this step, what they will do is they will write it like this: log 10 64 and then minus log 10 2. Okay, they apply the relationship between the logarithms. Alright, okay, they make it into like this. This is wrong. Okay, remember, it's not the same. Okay, these two things are totally different. So please, I know you like to simplify things, but you don't simplify this one into like this and then you change it into like this. Wrong. This is totally wrong. You will get a totally different answer. Alright, if you don't trust me, you can just try and punch in your calculator. Okay, the reason being is that because this one you are logging a fraction, okay, but this is not a fraction, this is two different integers. Alright, so you cannot change it into like this. Okay, always remember this. Alright, creative one, don't simply simplify. Alright, okay, So that is the conversion of base, meaning you can change the base. Another type or another way that you can change a base is that when you switch the two numbers here. Alright, so this one, if I want to change it to log base b, okay, b base log, alright, you just put a 1 on top. Basically you divide this, alright, 1 divided by b over log ba is equivalent to this. This is how you change the numbers here. There are certain questions that you might need to apply this, okay, so maybe there are one, I think there's one or two questions at the bottom that you are going to apply this thing. Okay, so that is the conversion of base. Now second part is this natural logarithm. Okay, so what is a natural log? So technically natural log we are referring to, okay, we are actually referring to the exponent base log. So meaning is this one, log e. Alright, so the e here is referring to exponent. Okay, exponent, exponent, x e p n t. Okay, exponent base. Okay, this is what we call exponent base. Alright, log e. So instead of a number, now the what we call the base is an alphabet. Okay, this e here refers to exponent base. And another way for us to write log e, in other words, they simplify lah. Instead of writing log e, they simplify into this one, ln, ln. So on your calculator, you should be able to find the what they call symbol for ln. Okay, mine is here. Okay, ln. Okay, and then also on your calculator you will be able to see the alphabet e, okay, the exponent, right? So technically this is what we mean by natural log. So if the question asks you to convert using natural log, meaning you need to change it into this form, log e and then ln. Okay, so I'll show you an example right here. Okay, so first question is by converting to base 10. Okay, so this one is very simple. They already tell me that I need to convert into base 10, right? So first question, oh my god, my dog. Okay, so log 15, base 15, so I change it into base 10, meaning I change it into log 10. Okay, on top stays on top, divided by log 10, 15. Okay, so once I change it into base 10, technically you just punch in your calculator. Alright, log 5 divided by log 15. Okay, and then you should get your answer 0.549. Alright, normally they will ask you to leave it in 3 decimal places. Okay, question 2. Alright, remember this is a decimal point, right? You change it into fraction. So log 2, 0.25 should be 1 over 4. Okay, so same thing, you change it into base 10. So log 10, then on top, this is on top, 1 over 4 divided by log 10, 2. Okay, so you just punch in your calculator. Alright, so log 10, 1 over 4, okay, divided by log 2. Okay, log 2. Okay, so this one you will get the negative value, if not mistaken, it's negative 2. Okay, so that is how you change the base, right? Basically, you change it into the same base. You separate. Okay, top remains top, bottom goes bottom. Right? Okay, next. Okay, this one. Convert to natural log and evaluate. So natural log meaning is this. Okay, log the exponent base. Okay, so how do we do this? Also the same thing. Alright, so log 7 220. Okay, we change it into exponent log. Okay, exponent base log. So meaning it's going to look like this. Log e 220 divided by log e 7. Okay, and then we know that log e is also equivalent to ln. So technically we can immediately change it into this form. Ln 220 divided by ln 7. Okay, so you just punch in your calculator. Ln 220 divided by ln 7. okay, and then you will get your answer. So this one is 2.772. Okay, so for question B, alright, so log 9335. Okay, so I can straight away jump onto this step lah. Easier for me because log E, right, same as log. So immediately I change it to ln 335 divided by ln 9. That's it. Okay, so this is natural log. Okay, so basically you just punch your calculator. Make sure you punch correctly, please. Oh my god, there are a lot of you who punch calculator. Also, you punch the wrong number. Oh my god. Alright, so 2.646. Okay, hopefully I calculate correct. Huh? Alright, okay, so that is natural log. Okay, so technically, it's just log E, also equivalent to log. Okay, alright. Next, okay, I'm going to show you some typical questions that they normally use when involving the change of base. Now here, alright, we know that you need to change the base, but what number should I change it to? I mean, my C can be equal to any number, right? So don't worry, questions itself will tell you that you need to change to which number. Okay, so if you look at this question, log 32 is equals to t. Express the following in terms of t. Alright, so if they already given me this, okay, technically I know, right, that my base number that I need to change to is 3. Easy, right? So A log 9 8, because this is different base number. Alright, when it's different base number, you have to change it. Okay, so log 9 8, I change it into log 3, since they already tell me it's log 3 2. So I change it to log 3. 8 is 2 to the power of 3. Okay, divided by, okay, log 3 9, right? 9 is 3 to the power of 2. Okay, so technically this one will become 3 will bring in front. So log 3 2 is equal to t. So this will be 3t divided by 2. Okay, this is 1. 2 will bring in front. So the answer here is 3t over 2. Okay, so basically that is how you change the base number. Okay, again, second question. Okay, 18. Alright, 18, I think I need to factorize this. Okay, no problem. I change the base number first. Alright, so let us change this one to log 318 divided by log 3 2. Okay, and then you know that 18 you need to factorize, right? So log 318 I can factorize using 9 and 2. Okay, so this one will be log 3 9. Yeah, write it complete a bit for you all. Okay, so log 3 2 is equivalent to t. Then log 3 k9, you know, is 3 to the power of 2 plus, because this one is multiply, so if you expand it, then it becomes plus over t. Alright, so this one will be equivalent to 2 plus t over t. Okay, so technically that is your answer. Okay, so that is how we use this to solve. Alright, previously during my years lah, which is like long time ago, okay, we love to use this to solve questions because it's very easy. Alright, because we can change the base number to any that we want. Alright, so please make sure that you know how to change the base number. It's very important. A lot of questions will require to use this to solve. Okay, so that is the oops, I shift it here. Alright, so that is the solving using change base number. Okay, let me show you another example here. Alright, given that log 2 is equal to this, base 2 is equals to 2.322. Without using calculator, find the value of log 15.6. Okay, some students will ask, okay, how do I know when should I use the change in base? Okay, now if you notice previous exercise, we have similar question. For example, like this, right? Okay, if you notice here, this question and the question below is very similar, but there's one key difference here. If you notice here, the base numbers are the same. Okay, this is log base 5. Okay, this one is also 5. Base number is 5. This is also 5. Okay, so in this case, you do not need to change the base. Alright, now for the example here, if you notice the base number is different. So this is base 2, this is base 2, but this is base 15. Okay, so it's different base. So when it's different base, okay, that is when you need to use the formula to calculate. Okay, so you change this one into base 2. Alright, so let us try and do this. So log 15x, oh not 15x, 15.6. So I change it into base 2. Okay, so log to 6 divided by 15. Okay, and then you need to factorize. Okay, so log 6 is the same as log 3 plus log 2. Okay, and then divided by log 15. This one will be log 5 plus log 3. Okay, so once you change to the same base, then you can solve the problem. So this is 1.585 plus this is 1, okay, divided by log 5 is 2.322 plus log 3 is 1.585. Okay, so time to use your calculator. So 1.585 plus 1 divided by 2.322. Oops. 5, and then you should be able to get your answer is 0.662. Okay, normally they will ask for 3 decimal places. Alright, okay, so that is how you solve. So remember, when to know that you need to change the base is if you notice, right, here the base numbers are different, then it's possible that you need to change the base number. Okay, so that is the example right there. Alright, so for example, if you see here, let me just show you one example where the base number is different. Okay, for example, this, right, this is base 2 log, okay, but this is base 8, so the base numbers are different. So this one you need to change it into base 2 first. Okay, alright, what about for question 4? Okay, if question 4, if you notice, right, this is base A log, right, whereas this one is base 15. Now this one you could actually use this, okay, to change the base. Alright, so this is base A log, right, log AB, so meaning this one I can change it into base A by using the relationship just now. Okay, so log 15A is also equivalent to 1 over log A 15. Okay, so once you change it into the same base, then you can solve the equation. Alright, so those are the examples. Okay, a lot of exercises here. Do try. Alright, next part will be involving the solving part. Okay, so I've included all the important formulas here. Alright, so it's easy for you to refer. You don't have to like keep flipping frontwards. Okay, and then I included a new thing inside here to help you solve any problems now. Alright, so if you see any numbers where you have the same base number, log ax equals to log ay, meaning that x is also equivalent to y. Okay, this is the new one that I've added in Okay, maybe you can use this to help you solve your questions. Alright, and then I've included the formula for the exponent base or the natural log. Okay, so remember these are the relationship. Log 10 is equals to 1, ln e is also equals to 1. Okay, the reason being, remember we say ln is also the same as what? Log e, right? So technically if you write it log e, same number, right? That's why it's equals to 1. Okay, log 10 also the same thing, because when we write it like this is referring to log base 10. Okay, remember? Okay, if we don't have a base number here, it's referring to base 10. So log base 10, 10 equals to 1 lah. Alright? So ln e is also equivalent to log 10. Okay, and then this is also another important relationship that you must know, that when you put a ln in front of an exponent, okay, you'll get back the x value. Alright, so let's say for example, if I punch in my calculator ln, okay, ln, and then you should be able to get your e. Alright, ln, let's say for example, e to the power of 5, let's say. Alright, not sure whether you can see this. Alright, but when I punch ln e to the power of 5, I get back the answer is 5. Okay, so remember this relationship right here. Okay, and then e to the power of ln also you get back x. Okay, so this one you are going to use it during your simplification or solving problem part. Alright, so let's look at the examples where we would apply all these things. Okay, so first question, solve the following equation. Give your answer in 3 decimal places. Okay, this one, alright, okay, what we can do is we are going to log both sides with the same base. Okay, easy is log 10. Alright, log base 10. So technically I'm just going to put a log. Okay, log 3x minus 4 equivalent to log 5x minus 3. Okay, and then I can bring this one and this one to the front. Okay, so it will be x minus 4 log 3 equivalent to x minus 3 log 5. Okay, then what we're going to do is we're going to multiply the log in, right? So this will become x log 3 minus 4 log 3. Okay, x log 5 minus 3 log 5. Okay, now once we reach this state, what we are going to do is the same unknowns, we are going to put it at the same side. Okay, so I'm going to shift this to this side, and then this 4 log 3, I'm going to shift it to the other side. So technically it will become x log 3 minus x log 5 equals to, this is negative, right? When I shift it, it becomes positive. So 4 log 3 minus 3 log 5. Okay, and then I'm going to factorize the x out, because I need to solve, meaning I need to calculate what is the value for x. Alright, so this one steps are a bit longer. Okay, and then x is equivalent to, okay, you shift the whole thing down, meaning you divide. Okay, divide this. Log 3 minus log 5. Okay, and then you should be able to get your answer. Okay, so let's try 4 log 3 minus 3 log 5. Okay, divided by log 3 minus log 5. So the answer that I should get is 0.85. 1.49. Okay, so that is the answer. Right. Okay, here comes again. Very creative students. I know, got questions. Do I really need to do all this steps? Okay, some of you very creative one, I know. What you will do is like this. Okay, so I'm going to show you another way. Creative students way of doing this. Alright, so they feel it's too troublesome to do all this. Okay, 太麻烦. Alright, so they will ask, hey teacher, can I just straight away divide like this? Here bring here bring here, can? So meaning I do like this, x minus 4, x minus 3, and then log 5 divided by log 3. And then they calculate what they call log 5 divided by log 3. So what is the, so this one you are going to get 1.465, and then they bring this up again, they multiply back, so you will get x minus 4 equals to 1.465x minus, okay, 3 multiplied to this, what do you get? 4.395. And then they rearrange. Okay, same unknown, same side. So x minus 1.465x equivalent to 4 minus 4.395. So this one you factorize the x out, so it will become like this. Okay, so 4 minus 4.395, you should get 0.395. Alright, negative 0.395. Okay, and then this one, okay, 1 minus, so this one will be negative 0.395. Oops. Okay, divided by, this is 1 minus this, right? So it's negative 0.465. Why does this thing keep popping up? Okay, so let's check what is the answer. Is it the same as previously? Fine, and 465. 465. And the answer that we get is okay, 0.849. Same answer. Okay, but there is a catch here. If you do it like this, right, make sure that when you calculate for when you divide the logs, okay, do not change this into 2 decimal place or into a whole number. Make sure that you leave it more than 3 decimal place. If not, your final answer might be slightly different, okay, compared to if you use the earlier method. Alright, so technically both ways can be used to calculate, just that this one is slightly more risky, alright, because of the decimal points here. Okay, if you convert it too earlier on, okay, your final answer might be slightly different. Okay, so it's best that you use the earlier method, although it's much more troublesome, but at least you know the final answer that you get will be the most accurate one. Alright, so that is the first question solved. Okay, so next is about this one. Solve the following natural log equations if answered in 3 decimal place. Okay, so here is ln. Okay, so for this one, what we are going to do is, I know that I need to shift this to the other side. Okay, but there is no formula that says shift ln, no such thing, right? So we can write this one, remember, ln is equals to log e. So I can change it into log e. Okay, and then 4x minus 2 equals to 5. And then I can shift the log to the other side. So this one will become 4x minus 2 equals to e to the power of 5. Okay, Now this one no choice, you need to use your calculator to calculate. Okay, so you find the what you call alphabet, okay, e to the power of 5, okay, and then you will get your value. So this is 4x minus 2 equals to 148.413. Okay, e to the power of 5, and then you shape it. You just solve this as a normal way. Alright, so 148.413 plus 2. Alright, so this one x will be equal to, this is plus 2, right? So 150. So 150. Why does this keep popping up when I write 5? 0.413 divided by 4. Okay, so let me just check my answer just in case I calculated wrongly. 4, and then you will get your answer here will be 37.603. Okay, 3 decimal place. Right, so that is how you solve. Okay, now what about for the second question? You have an unknown here. Okay, 2x. Alright, so this is 10e2x. Okay, of course, first thing you do is you shift the number to the other side. So it's divide. So e2x also equals to 2.2 because divide 10. Now, how can we bring the x down? Okay, we are going to use the relationship here. Okay, remember that if you put a ln in front, ln ex, you get back the x, right? So what we are going to do is we are going to put the ln in front. Okay, so it will become like this. Ln e to x equals to ln 2.2. So this is removed. So it becomes 2x equals to ln 2.2. And then you can just solve the equation. Ln 2.2 divided by 2. Okay, so ln 2.2. Oopsie daisy. Divided by 2. Okay, 0.394. Okay, so technically that is how you solve the equation. Alright. So you're going to use a lot of this one. This then log e as well. Okay, you need to remember that ln is also equivalent to log e, and then you need to learn how to play around. Alright, so you need to do more exercises. Okay, alright. Okay, the final one, solve the equation. Okay, this does not involve the exponent base, it's just like a revision. Alright, remember, same base number, same logs, you put at the same side. Okay, minus 2, and then y minus 7. This is equals to 3. So since this one is minus, I simplify it. Log 2 y divided by y minus 7 equals to 3. And remember, you shift the log to the other side. So y over y minus 7 equals to 2 to the power of 3. So y equals to, oops, 8. Oops, equals to 8. Alright. And then you're just going to cross multiply and then just solve the equation. So y equals to 8y minus 56. Okay, and then same unknowns put together. Okay, so y minus 8y equals to negative 56. Except by y, a lot of y here. So equals to 8. Alright, so hopefully I calculate correctly. Let me check back again. Blah, 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 blah. Okay, should be correct. So that is the answer. Okay, that is how you solve. Alright, so that will be it, I believe. okay, solving equations, so you need to look, right? For example, this 3x is equals to 5. Okay, now questions like this, right? How to know when should I use the log or the index value is because that you know this one is not a multiple of 3. Okay, meaning you cannot convert it into like 3 to the power of what, because 3 to the power of what does not equal to 5. So in this case, um, the easiest way is for you to use log. Okay, you put log at both sides. Okay, and then you should be able to calculate. So let me just show you lah. Right, so let's say for example this one log 3x equals to log 5. So this one x I can bring in front. Okay, and then I can just solve this. Log 5 divided by log 3. So just punch your calculator. Alright, so you should be able to get your answer. Okay, so a lot of exercises here. Try. Alright, you need to look at the questions when you need to change your base. Right, do you need to change your base or do you not need to change your base? Okay, right. So 4.4 is basically like a summary of what all that you have learned in throughout the chapter. Indices, I'm not sort, surds and logarithms. Okay, so you need to learn how to play around, how to convert, right, in able to able to solve all the questions. Okay, don't worry. I will discuss this later on, right, once you have completed all the exercises. So that is it for today, and I believe that ends chapter